Hey guys, and welcome back. Today we are talking about orbital diagrams, and I'm going to need you to stay with me in this lesson today because it can get a little bit tricky, but I am confident that you guys will be super successful at it. Now, if you have not done your electron configuration lesson yet, you need to make sure that's complete because if you don't understand electron configuration, this is going to be especially tricky. So without further ado, let's go ahead and get started. So today we're talking about atomic orbitals. Now, we have to define that before we can create a diagram based on these orbitals. So an atomic orbital is the region of space surrounding the nucleus. This is where the electrons are found, and it just describes the movement and the shape of the electrons. So up until this point, we have done Bohr models where we fill those electrons in on those energy levels, but Bohr models are a very 2D representation of the atom, right? It's just flat. It doesn't really show a 3D representation of what an atom looks like in reality. So as we see here on the screen, these electrons are moving in the cloud around the nucleus, and they move in different shapes based on which orbital they're in. And the orbitals have different shapes, which I'm going to show you here on the next screen. So s orbitals have a spherical shape. P orbitals have this kind of like figure 8 shape. D orbitals are clover, and then F orbitals are kind of like a flower. Okay, so again, these orbital shapes just mean if you have an electron that, let's say, falls in a p orbital, that means the movement around the nucleus is going to move in this kind of figure 8 shape. And remember, with electrons, we can only really ever predict the likelihood of where it will be around the nucleus. So it just means that an electron in the p orbital will be somewhere in this region and it will follow this shape, okay? So it just tells us the movement of the electron around the nucleus. So when we're using orbital diagrams, this is basically just going to be a visual representation of the electron configuration. Okay, so you already know how to do electron configuration given the table and that configuration map. In this case, we're just going to represent that visually. Okay, so it's going to be a visual representation of the electron configuration, and it helps us just kind of chart the pattern of the movement. So today we're talking about shells, subshells, and orbitals. So I just wanted to define that really quickly so there's no confusion as we go throughout this lesson. So the shells are going to be the entire energy level. Okay, so the shells are going to encompass everything in that energy level, aka if you're looking at the like the periodic table, it would be like an entire period, right? So the energy levels are coming from the periods. It's everything encompassed in that shell. The subshells are going to be the orbitals of a specific shape. So like a p subshell would be all the p orbitals, okay? So like in this specific example, the third energy shell has a d subshell, a p subshell, and an s subshell. And then the orbitals are going to be the individual boxes that we see, and the orbitals can contain up to 2 electrons, okay? So any single orbital can hold a max of 2 electrons. So like in this case, our 3p single orbital can hold 2 electrons, okay? Our 3p subshell can hold up to 6 electrons, right? Because it can be 2, 4, 6, right? Our entire energy shell can hold 2, 4, 6, 8, 10, 12, 14, 16, up to 18 electrons, okay? So again, each box can hold 2, and then the subshells, it will depend on which subshell it gets. Okay, we'll talk about that a little bit more on the next slide. And here's just another visual representation. Again, the whole shell is the entire energy level. The subshells will be the shapes, and then the orbitals will be how many of each shape there is, essentially. So for S, there's always 1. For P, there's up to 3. And then for D, there's up to 5. And then there's F, which is up to 7. Okay, so how do we fill these shells, subshells, and orbitals? Like, what is the process for this? Well, when we're drawing this diagram, each shape has a specific number of orbitals that they can get. And remember, we already said that each orbital only gets 2 electrons. Okay, so this is going to help us determine how many electrons each subshell or each shape is going to get. So the first one is the S, and S gets one box. Okay, so S orbitals, they get one box. P gets 3 boxes, so that just means P's can have up to 3 orbitals, okay, because each box is an orbital. So S gets 1 orbital because they can get up to 2 electrons. P has 3 boxes. The P's can have up to 6 electrons. D gets 5 boxes. So when you're drawing these out, your D sublevels would have 5 boxes, and then F would have 7. Okay, so again, remember this tells us the maximum amount of electrons that can be in each of these. So S, 1 box, that means up to 2 electrons. P, 3 boxes, up to 6 electrons. D, those 5 boxes, those 5 orbitals, up to 10 electrons. F, 7 boxes, remember 2 electrons in each box, which is each orbital, up to 14 electrons, okay? As you move up towards the F shape, it's higher energy, okay? So the S is going to be the lowest energy up to the F, which will be the highest, okay? So those are the boxes that we are going to add our electrons to. But there are certain rules that we're going to follow when we're creating these diagrams. So the first one is the off-ball principle. And basically, this is just using the sequence of atomic orbitals from lowest energy to highest. So these are going to be the S, P, D, and F, okay? So this is basically just telling us that we have to start filling with the lowest energy first, okay? So that just means we're going to start with our 1s, then we'll go to 2s, then we'll go to 2p, then we'll go to 3s, so on and so forth, okay? So the off-ball principle just states that electrons are going to fill from the lowest energy to the highest energy. So we always start at the bottom with that 1s, and then we move our way up depending on how many electrons the atom is going to have. Okay, so off-ball principle, we're always starting at the bottom. The Pauli exclusion principle states that a maximum of 2 electrons can occupy a single atomic orbital. Remember, I already said that each box, each orbital gets a maximum of 2 electrons. But this is only the case if the electrons have opposite spins. Okay, so they occupy a single orbital if they have opposite spins. For us, that means when we're drawing these orbital diagrams, it just means that if we have 2 electrons in an orbital, so if we fill 2 electrons in a box, they're going to have opposite directions. So you're going to draw an arrow up and then an arrow down. We never want to draw these with arrows in the same direction because they wouldn't fill that way. Okay, so the opposite arrows are just indicating that the electrons have opposite spins. Okay. And then finally, our last rule is Hund's rule. So this states that single electrons with the same spin must occupy each equal energy orbital before additional electrons with opposite spins can occupy the same orbital. Okay, that's a really big mouthful for saying that when you get to like a P sublevel that has multiple boxes, you have to make sure there's 1 electron in each box before going back to fill in the opposite arrows, okay? So these electrons, remember, these arrows represent the electrons, and remember, we calculate the electrons from the atomic number. So like the example here with nitrogen, this is the atomic or the orbital diagram for nitrogen. He's got 1, 2, 3, 4, 5, 6, 7 electrons, okay? He's got 7 electrons because his atomic number is 7. So when we're filling these orbital diagrams, we have to follow those rules, right? So we fill the lowest first. We always add the upward arrow to the box, then go back and fill with the down arrow, okay? When you get to a sublevel, with more than 1 box, you have to fill in each box before you can go back with your opposite arrow, okay? We'll do some examples, but this will definitely make more sense when we start to do these ourselves, okay? So here are the steps you're going to follow for writing orbital diagrams. 1, you're going to write the electron configuration. 2, you're going to draw the orbital diagram. 3, you're going to fill in the spin based on the number of the electrons. We're going to follow those 3 rules. And then for each block, we're going to fill the arrows first and then fill the down arrows. So up arrows first and then down arrows. So we're going to do an example here of sulfur. Okay, so we're going to do sulfur together, and I'm going to find them on the periodic table. All right, so sulfur's atomic number is 16. So I know when I fill this orbital diagram, there's going to be 16 arrows. Okay, it's just the number of electrons, so it's an atomic number. So I know there's going to be 16 electrons, right? So 16 electrons that I'm going to have to fill. And I need my electron configuration because that's going to help me, right? So sulfur, he's right here. He's in the P block in the 3rd period, so he's 3p4. So our electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so that means when I get to my 3p subshell, there's going to be 4 electrons in that box. Okay, so let's take a look and see what this looks like. So there is our electron configuration that we just did. Again, that's why I said if you don't know how to get electron configuration, you just got to know how to do that at this point, okay? So if you still need help with that, please let me know. All right, so now we're going to start to fill. Now remember that off-ball principle says we have to start at the bottom. So we'll always start with 1s. Now you guys are not going to have to draw these lines out because we're virtual. I'll always give you the boxes. You just have to be able to identify them and also to fill them with the arrows. So we always start with 1 first. Remember, we've got 16 total electrons that we have to fill. So at the end, there should be 16 arrows. So we're going to start with 1s. We're going to fill up arrows first and then come back and fill down. Okay, so each of these lines is an orbital box, so each can have up to 2. Okay, so now that we've filled 1s, we can fill 2s. 1, 2. Okay, so at this point, I've filled my 4 electrons. Okay, now the s orbitals can only have up to, well, each orbital can only have up to 2 electrons, but the s sublevels, there's only 1 orbital, so your s's are only ever going to get up to 2. Okay. Now our p sublevels, remember, they can have up to 3 orbitals, which means up to 6 electrons. So now we're going to fill, but remember, we have to fill the up arrows first. So if we were doing this, we would go 1, 2, 3, and then come back and fill our down arrows. Okay, so you have to fill them with the same spin in the orbitals first, and then come back with the opposite spin arrows. Okay, so at this point we've got 2, 4, 5, 6, 7, 8, 9, 10 electrons. So we're not done because remember sulfur has 16, so we have to make it to 16. All right, so next we're going to 3s, right? So up and then down. So now we're at 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means in our final subshell, we're going to need to finish out the configuration. So this 3p should have 4 electrons. So we're going to fill each individual box with the upward arrow first. 1, 2, 3, and then come back with our down arrow to finish it out. Okay, this is the orbital diagram for sulfur. Okay, and again, we're writing out the electron configuration so we can double check ourselves, right? So our S2, our s orbital, our first s orbital should have 2 electrons. Our second s orbital should have 2 electrons. Our p orbital, our 2p should have 6. Our 3s should have 2, and then our 3p should have 4. Okay, so just make sure you have the correct electron configuration, and then you can double check your orbital diagram against it, right? These can be tricky. You just want to make sure you're following those 3 rules, those 3 principles as you're doing these orbital diagrams. It will take some practice, but definitely once you start to do a few of these, it will start to click in place for sure. If you need help or have questions, as always, please come to office hours or shoot me an email. And if not, I will catch you guys in our next lesson.